For 70 years, we've trained ourselves to speak to machines in a very specific language. We write explicit, deterministic instructions. 1 + 1 = 10 in binary. If X, then Y. It's rigid, and it executes perfectly. This paradigm goes all the way back to the origins of computing, wired into our professional psychology by the earliest architects of the digital age. So when we sit down in front of a large language model, we instinctively apply that exact same logic. We write prompts that look like software specifications, stacking up rigid rules, bulleted lists, and strict negative constraints. Give a language model a rigid framework, and it will force every idea into that identical shape. Ask it about nuclear physics or how to bake an apple pie, and you get 4 neat subpoints, over and over, regardless of the actual complexity. When we try to force this fluid system to act like a rigid processor, we don't get precision, we get friction. We are attempting to use the tools of formal logic to control a machine that operates on an entirely different frequency. To fix the output, we have to let go of the idea that the model is remembering what we tell it. It has no long-term memory of your chat session. Instead, think of it as an amnesiac actor. Every single time you press submit, the model gets a fresh start. It wakes up entirely blank, with no idea who you are or what just happened. All it has is the context window. The complete record gets dumped onto the actor's lap all over again, the entire script on every single turn. The model reads those pages and statistically guesses the next line of dialogue to complete the pattern. Because it starts fresh every time, its responses are dictated entirely by the visible patterns in that window. If your explicit rules contradict the tone of the conversation you've established, the model will follow the pattern every time. This means every prompt is homoiconic. The structure, the typography, and the very shape of your request are themselves data. Imagine asking the model for flowing, lyrical prose, but formatting your request as a numbered, clinical checklist. The result is almost always a stiff, constrained response. The model mimics the checklist format it sees in your prompt, effectively drowning out the request to be creative. Now, take that exact same request, but write it as a flowing, evocative paragraph. The output instantly shifts to match. The model mimics what you do, not what you command. You can leverage this mechanism. Referencing a specific author hands the model a stack of notes about their worldview and style, pulling an enormous volume of latent data into its focus, without you writing a single instruction. Even tiny typographic choices have mass. A popcorn emoji warps the probability of the next word, pulling in concepts like cinema and enjoyment. Words like savant do the same thing, dragging the math toward highly competent language before the model even begins to reason. Prompt engineers don't write if-then statements. They design semantic gravity wells that load the dice for the exact outcome they want. You are stepping away from transactional commands and entering a cyclical feedback loop. Every output the model generates becomes part of your next input, shaping the trajectory of the conversation. Rather than building a walled garden of rigid constraints, you are planting a seed. The final output is a crystal growing from a seed, where each new layer mimics the structure of the environment you established at the start. The most effective way to control this is through persona design. By defining the character and the typographic stage up front, the model naturally falls into the desired behavior because it's the path of least resistance. Coding is the art of building a predictable flowchart for a processor. Prompting is the art of building the semantic environment for a specific thought to emerge.